There are three main types of pacemakers that you will see in 99% of pacemaker patients. These are a single chamber pacemaker, a dual chamber pacemaker, and biventricular pacemakers. The titles are quite self-explanatory. You can probably have a think already what they'll mean, but we'll look at them in greater detail now. A single chamber pacemaker has one lead. Now it can either go into the atria or the ventricle. We'll come on to that in a moment. But the single chamber pacemaker's lead is passed through a vein. This is usually a cephalic or a subclavian vein, down through the superior vena cava and into the right atrium where it is attached. These pacemakers are most commonly found in patients with sinus node disease. These patients will not have heart block or any block further down the conduction system. As mentioned, a single chamber pacemaker can also be one with a ventricular lead and no other leads. The ventricular lead is positioned in the same way, goes through the same veins, but this time it is passed through the tricuspid valve and attached somewhere in the right atrium. This is quite commonly at the right ventricular apex. These pacemakers are most commonly seen in people with atrial fibrillation, and we'll explain why later. Another common type of pacemaker is the dual chamber pacemaker. If you hadn't guessed it already, this pacemaker has two leads, one positioned in the right atrium and one positioned in the right ventricle. These pacemakers are most commonly seen in patients with a heart block. Another type of pacemaker is the biventricular pacemaker. These are slightly less common than the others we've seen, but still make up for a large percentage of pacemaker patients. Biventricular pacemakers always have a right ventricular lead and a left ventricular lead. The left ventricular lead is positioned in a slightly different way, and it's shown here in purple. So the lead is passed through the same venous network to begin with, down through the superior vena cava, but at this point, instead of being attached, it is passed into the heart's venous network via the coronary sinus. It then goes out the back of the heart, round one of the coronary veins, and then is wedged into position on the external wall of the heart. In biventricular pacemakers, you always have a right ventricular lead and a left ventricular lead, but an atrial lead is not always used. When I think of functionality of pacemakers, I always think of televisions, which may sound like a strange analogy to make. But with televisions, you can have a standard TV, you could have a TV and DVD player, or you could have a TV, DVD player and surround sound. Now, all that means is that a television is ultimately a television, but the more hardware you have, the more functionality you have. And that is true of pacemakers. Essentially, they'll do a very similar job, but the more hardware, the more leads you have in situ, generally speaking, the more functionality they have. So the takeaway message, remember that complex devices can do all the basic things that simpler devices can do and more.